Welcome everyone. I'd like to have you participate in this online training. This first one will be done with just an introduction to mosquito abatement and the things that we do here. And I'm going to share with you a PowerPoint. I'll walk you through it. Let's see. All right. Should be able to see then. 10 minutes. Glad to have everyone back. I want you to understand. And what ways to help unite things we do. Just some thoughts on COVID and changing how we operate, social distancing in the office, stay 6 feet apart, best we can, don't hover over Becky's desk, wash your hands when you come into the office, don't hang out in the conference room, come in, get your stuff, be out on your way, wipe down your trucks at the beginning and the end of each day. We appreciate that. And if you would, wipe down the door handles, steering wheels, and things you've touched. And then wear a mask when engaged with the public. We work for the health department. And we're trying to set an example. So why do we do mosquito abatement? Well, mosquito abatement affects the mosquitoes' effectiveness, their quality of life, to annoyance, causing the sheer numbers of mosquitoes, the increased impact on domestic animals and wildlife, devastating economic problems and negative impact on local economy, and they're vectors of some of the nastiest diseases in the world. So it's a vector for diseases. These are a list of many of the diseases that we have in North America. The ones that are in red, West Nile, St. Louis encephalitis, Western equine encephalitis are those that we are most concerned with that are here in Utah, of which West Nile is the one that is here in the dominant effect. The West Nile virus, well, is a member of the Flavian viruses, and it belongs to the Japanese encephalitis antigenetic complex of the family Flaviidae. The Flaviidae is a family of positive single-strand enveloped RNA viruses. Some of the mosquitoes transmit the virus from this family include yellow fever, dengue fever, Japanese encephalitis, West Nile, and then Zika. Those are all very closely related. The origin of West Nile was the first isolated in a woman in the West Nile district of Mungo, Uganda, in 1937. Thus its name. It then was identified in birds and crows in the Nile Delta region in 1953, cause of human meningioencephalitis in Israel. In the elderly in Israel in 1957, there was an outbreak in southern France in 62, and the virus was fatal in horses in France in January of 65 in Egypt. The outbreak in South Africa was again in 1974, then an outbreak of more serious symptoms in Romania in Budapest, 96. Then the migration will continue. In 1997, it became pathogenic in birds, and in 1999, it was circulated in Israel and Tunisia and was imported to New York. It was found in New York in 1999 by killing of birds, and it spread to New Jersey, Maryland, and Connecticut. We had 62 birds die, or U.S. cases with 7 fatalities. It reappeared in New York in the 2000s, and then massive outbreak in the U.S. in the Mississippi River Basin in August 2003, as you can see there. Okay. It may have been a result of changes in the genetics of the virus. For example, amino acid substitution in the chikungunya virus that allowed for affected vectors by the Aedes albopictus mosquito. Amino acid substitute in the West Nile virus increased viral replication of the avian host and led to the North American epidemic. Watch as it moves across the United States. Here are the numbers in Utah, including last year, 2019. Some things I want you to notice is that in 2006, we had 5 deaths. 2017, we had 5 deaths. We had a lot more cases in 2006 than we had in 2017. But the same number of deaths. Notice that last year, the year before, we had 2 and 1 death associated with it. These are human deaths. Key factors about West Nile can cause fatal neurological diseases in humans. However, approximately 80% of people who are affected will not show any symptoms. West Nile virus is mainly transmitted to people through the bites of mosquitoes, infected mosquitoes. It can cause a severe disease or death in horses. Usually about 9 out of 10 die. Vaccines are available for use in horses, but not available for people. Birds are the natural hosts for West Nile. Humans' infection most often result in a bite from an infectious mosquito. The mosquito becomes infected when it feeds on infected birds. It circulates the virus into their blood for a few days. The virus eventually gets into the mosquito salivary glands during a blood meal. The mosquito then passes the virus into humans or other animals, which will cause the illness. We are a dead-end host. We just don't get a high enough level. It can be contacted through other infected animals, through blood or other tissues. A very small portion of human infections have occurred through organ transplants. To date, no human-to-human transmission of West Nile has occurred, and no transmission of West Nile virus to health workers have been reported when standard infection control precautions have been placed in effect. There has been some transmission of that to laboratory workers. Signs and symptoms. Infection with West Nile is symptomatic, no symptoms in around 80%, as we've said. People who can lead, or people can lead to a West Nile fever or severe West Nile disease. About 20% of the people who become infected with West Nile will develop a West Nile fever. Symptoms include fever, headache, tiredness, and body ache, nausea and vomiting, occasional skin rash on the trunk of body, and swelling lymph glands. West Nile encephalitis or meningitis is very severe disease, also called neuroinvasive disease, such as West Nile encephalitis, meningitis, or West Nile poliomeningitis. Includes headache, fever, neck stiffness, stupor, disorientation, coma, tremors, convulsion, muscle weakness, paralysis. The incubation period is usually 3 to 14 days. It's estimated approximately 1 in 150 people infected with West Nile will develop a more severe form of the disease, and can occur in any ages. However, people over the age of 50 and some immune-compromised person are at higher risk of contracting West Nile fever. We diagnose it a number of different ways, from an IgA antibody serial conversion or significant increase in antibody titers in the 2 of the serial specimens collected in the 1-week intervals by enzymes linked. The ELSA assay. This is the active, the IgG is active, IgM antibodies captured enzyme linked, same way, but linked for this particular marker, which gives you a memory cell. And then you can do a neutralization assay of serial testing, and it will detect the presence and magnitude function. And then viral detection by reverse transcriptase, RT-qPCR. Treatment is supportive for patients with neuroinvasive West Nile disease, often involves hospitalization, intravenous fluid, respiratory support, and then prevention of secondary infections. There are no vaccines available for this. I'm going to stop there.